Again, we come up with a new question from Pathfinder Challenge Your Understanding section. And see this question. It's a very nice question from System of Particles and Rotational Motion. And if I see this question, it's very nice question with a lot of concept. First of all, let us go through the question. A hemispherical bowl is placed on a frictionless horizontal floor, and a small disc is placed on the top of the bowl, as shown in the figure. The disc and the bowl are of equal mass, and there is no friction between them. The disc is slightly pushed horizontally so that it starts sliding down the bowl with a negligible speed. At what angular displacement of the disc measured from vertical line through the center of the bowl will the disc lose contact with the bowl? So in order to solve this very nice variety question, so we have to consider the diagram, students. It is a hard to solve the question. So I have already plotted the diagram for this. So you can see this diagram. Okay, and if we see the diagram, so these are the very important components to solve the question. So here there is a bowl basically, and when the disc starts sliding down the bowl with a very negligible speed and at a particular angular displacement theta, the disc is going to lose contact with the bowl. Okay, so here, so the most important point is at the point when the disc sliding down the bowl will also move backwards because there is no friction anywhere. So here the task is to find out the angle theta from the vertical where the disc will lose contact with the bowl. So now, in order to solve this problem, we have to conserve the linear momentum along x direction because there is no external force acting along x direction. So we can comfortably conserve the linear momentum along x direction. So here v dash is the velocity of the disc with respect to bowl. I have resolved it into components. One is v dash cos theta, which is acting along horizontal direction, and another one is v dash sin theta, which is acting along vertical direction. And here I have taken the normal at the point where the disc lose contact with the bowl, and that normal is n. And also I have resolved the mg into components, that is mg cos theta and mg sin theta. And you can clearly see everything in the diagram. And disc will slide. The vertical displacement of the disc is capital R into 1 minus cos theta. Okay, and now we will proceed to the solution. So I am taking this as my reference level. That means 0 P level. We can take like this. This is my reference level to measure the potential energy. This is what just a reference level. So now let us attack the problem first. Let us enter into the solution by conserving the linear momentum along x direction. Initial momentum along x direction is 0. So final momentum along x direction must also be 0. So we will do that. So both the bowl and the disc both are having the same mass. This mass is m and this mass is m, and the bowl moving backwards and disc moving forward. So we have to take a proper sign convention here. So let us take this direction as positive and backward direction as negative, and apply momentum conservation. Let us write the final momentum. So that means we will write properly mass of the bowl into speed of the bowl, and we have to put a negative sign because we are writing this for bowl because bowl is moving backwards. Now for the disc is moving forward, so we will write properly the equation. So mass of the disc is also m, but we have to write the speed of the disc along positive x direction. Here, whenever we want to write the velocity of the disk in positive x direction, we have to take care because this v dash cos theta is the velocity of the disk with respect to ball, and the ball is also moving backwards. So according to the concept, we have to write the velocity of the disk with respect to ground as v dash cos theta minus v. So that must be equals to 0. So now we need to simplify it further. So see what we will get, because this is the final momentum, and we will simplify mv minus mv plus mv dash cos theta is 0, and we will write properly this mv dash cos theta is equals to 2mv. So this m going to get cancelled out, and v is equals to v dash cos theta divided by 2. So this is our first equation. Okay, so now we want to find out the velocity vector of the disk with respect to ball. Okay, v dash is the velocity of the disk with respect to ball. So what is the vector? So we will write properly. So v dash bar is equals to v dash cos theta, this is in x direction, and minus v dash sin theta, this is in y direction. So this is the velocity vector of the disk with respect to ball. Okay, so disk is moving backwards, so velocity vector of the disk can be written like this. Magnitude of the velocity of this is the velocity of the ball. This is the velocity of ball. So ball is moving backwards with the magnitude v, and the direction we will keep minus I cap. So this is the velocity of disk with respect to ball. Okay, so now let us proceed to the velocity of the disk with respect to ground. Velocity of the disk with respect to ground is equals to velocity of the disk with respect to ball plus velocity of ball. This way we will write. Okay, so velocity of the disk with respect to ball is v dash bar. So we will write here v dash cos theta I cap minus v dash sin theta j cap plus velocity of the ball, that is v into minus I cap. So finally, let us see the velocity of the disk. So that velocity of the disk is v dash cos theta minus v I cap minus v dash sin theta j cap. This is the velocity of the disk with respect to ground. Okay, so now we have to observe one more point very clearly from the diagram. So we have taken our reference level and we have applied the point where we are having the energies. Initially the disk is at the top of the ball. This is the disk. But later it's sliding down the ball, and at a particular point it's going to lose contact. So here we are taking this reference level as our 0 PE level. 0 PE level. So then we don't need this potential energy. This potential energy can be assumed as 0 because we don't have this term now. This potential energy term will be 0 here. We don't have this potential energy term. We can block this. This potential energy term will be not there. Only kinetic energy. Okay. So now we will write energy conservation from location 1 to location 2. This is location 1 and this is location 2, and this location we have taken as our reference. that means 0p level is chosen at 2. From 2 point of view, the disk is at location 1 and it is having only potential energy. And we will write like this. The initial energy is simply potential energy, that is the potential of the disk. So that is mg into r into 1 minus cos theta. So this is the initial energy of the system. But the point when the disk slides and coming to the location 2, at location 2 the bowel is moving backwards, the disk is moving with respect to bowel, so we have both kinetic energies. Anyway, we have taken two location as 0 PL level, so we no need to worry about potential energy. So we will directly write the energy at location 2, that means the final energy can be written like this. So that is simply the kinetic energy of bowel plus kinetic energy of disk. Okay, here kinetic energy of the bowel is half mv square plus kinetic energy of the disk is half m into speed of the disk square. Okay, so now we will continue further because according to conservation of energy, initial energy is equals to final energy. And we will write like this: mgr into 1 minus cos theta is equals to half mv square plus half m into speed of the disk square. Okay, but we already know the speed of the disk with respect to ground. We have to write it properly here. So we will take the speed of the disk and we will apply it here. We will see this very important result. The speed of the disk is, we have to take the magnitude, that will be square root over v dash cos theta minus v whole square plus v dash sin theta whole square. Okay, so we use our result here in this equation. Okay, so we already got our equation 1 and now we are using it in our equation 2. So see properly. So what we will get? So you can cancel m from the equation 2. So g into r into 1 minus cos theta is equals to half v square plus half speed of the disk square, that will be simply v dash cos theta minus v whole square plus v dash sin theta whole square. Okay, and we need to simplify the entire equation properly. So take this to the side and it becomes 2gr into 1 minus cos theta is equals to v square plus, and this will be v dash cos theta minus v whole square plus v dash sin theta whole square. Okay, so further simplification. So v dash square plus v dash square cos square theta plus v square minus 2 v dash v cos theta plus v dash square sin square theta, that is equals to 2gr into 1 minus cos theta. Okay, and further simplification, this v square and this v square to v square plus this v dash square cos square theta, v dash square sin square theta becomes v dash square plus yeah, everything is over. Next here minus we will take 2 v dash v cos theta and 2gr into 1 minus cos theta. Okay, but you already know the relation between v dash and v. V is equal to V dash cos theta divided by 2. So we are going to use that result. That means we are using equation 1 here. V is equals to V dash cos theta by 2. From this, V dash is equals to 2V divided by cos theta. And we will use it here. See what we will get. 2gr into 1 minus cos theta is equals to 2V square plus 2V divided by cos theta whole square minus 2 into 2V by cos theta into V cos theta. Okay, so see, we need to simplify this properly, otherwise we will get wrong answers. So we have to take a lot care in solving this question. 2V square plus 4V square by cos square theta minus 4V square we are getting. Okay, so we will take the 2V square out of this and we are getting 1 plus 2 by cos square theta minus 2. So that will be 2gr into 1 minus cos theta. So this is continued. But here this 2 and this 2 can be cancelled. Okay, and v square will be like this. Gr into 1 minus cos theta divided by this cos square theta will come here, and in the denominator we are finally having 2 minus cos square theta. So this is what we are having in the denominator. And this is v square. Okay, so we need to continue, but here if you see, students, what is the situation? This disk is sliding with respect to ball. At the point when the disk loses contact, the horizontal component of velocity of the disk will becomes maximum. The horizontal component of velocity of the disk will be maximum at the point when it losing contact with the ball. So that is the very, very important observation. And also the normal reaction will be 0. So we have to remember both the points. So we will write the point. So at the point 2, the normal reaction n will be 0 and horizontal component of velocity of disk will be maximum, and after that it becomes constant. But at the point when it loses contact with the ball, the horizontal component of velocity of the disk will be maximum. Okay, so this is a very, very important observation that we have to see in this question. So now we will do that. So see here. So what we are doing is we are putting the n value 0. So we will take n value 0 and we will do the remaining things. And here what will happen? Yeah, horizontal component of velocity of the disk will be maximum. Yes, so here we will take like this. What is the horizontal component of the velocity of disk? V dash cos theta minus v. Yes, so this will be maximum, so we will take that. So d by d theta of v dash cos theta minus v will be 0, because whenever it is maximum then it will be 0, because this is a function of theta. This is a function of theta. So definitely if it is maximum, then with respect to derivative derivative with respect to theta will be 0. We will already studied this same concept in maxima minima, and we will do the same here. So d by d theta of v dash cos theta is you've already seen that result here. V dash cos theta can be written as 2v. So 2v minus v will be 0. That means d by d theta of v will be 0. But here what is v? So this is the speed of the, this is the value of the v. Basically we have to do it here, and if d by d theta of v means we will take like this. So the square root over gr into 1 minus cos theta into cos square theta divided by 2 minus cos square theta is equals to 0. So this need to be 0. So I'm directly differentiating the inner function because this is a square root. So we will take directly the inner function differentiation and we will equate it to 0. So gr into 1 minus cos theta into cos square theta divided by 2 minus cos square theta is 0. So let us differentiate properly. So 2 minus cos square theta into differentiation of cos square theta minus cos cube theta minus here cos square theta minus cos cube theta into differentiation of 2 minus cos square theta is 0. So now we will differentiate. So what is the differentiation of this? This is 2 cos theta into sin theta minus 3 cos square theta into sin theta. Here also we have to do the same thing, cos square theta minus cos cube theta into, this is 0 minus 2 cos theta into sin theta is equals to 0. So that means you can remove sin theta from this whole equation and we will rewrite the equation properly. So 2 minus cos square theta into 2 cos theta minus 3 cos square theta minus cos square theta minus cos cube theta. So this minus becomes plus, and this is 2 cos theta is equals to 0. So we will simplify this. So this becomes 2 into 2, this is 4 cos theta minus 6 cos square theta, and this is minus 2 cos cube theta, and this minus becomes plus, and 3 cos to the power 4 theta, and this is 2 cos cube theta minus 2 cos to the power 4 theta is equals to 0. So we will see the simplification, and here 4 cos theta is there, and here 2 cos cube theta, and here minus 2 cos cube theta going to get cancelled out, and see the remaining things properly, and here this and this becomes cos to the power 4 theta. Next, minus 6 cos square theta plus 4 cos theta is equals to 0. Again you can remove one more cos theta and the equation becomes cos cube theta minus 6 cos theta plus 4 is equals to 0. So this is the final equation that we need to solve. So in order to solve this equation, we will take cos theta as x, then x cube minus 6x plus 4 is equals to 0. So here this can be written in the factorization form like this, x minus 2 into x square plus 2x minus 2 is equals to 0. So we will take this one, x square plus 2x minus 2 is equals to 0, So upon doing the factorization, we can find the roots for this. X is equals to minus b. Minus b means minus 2 plus or minus square root over b square. That is 2 square minus 4ac divided by 2a. So x is cos theta. So cos theta is equals to minus 2 plus or minus square root over. This 2 square is 4. Minus of minus becomes plus. 4 2 is 8 divided by 2. So minus 2 plus or minus this is 12. So 12 can be written as 4 into 3 divided by 2 and becomes minus 2 plus or minus 2 root 3 divided by 2. And if you simplify this, we are getting minus 1 plus root 3. And here we don't take the negative sign, we will ignore the negative sign and we will take the positive one. And cos theta will be root 3 minus 1. And here theta will be cos inverse root 3 minus 1. So this is the angle at which the disk is going to lose contact with the bowl. So this is a very nice question from Pathfinder. Hope you enjoy the solution. Okay, thank you students. Bye.